So today we're doing this quiz on 11.2 and 11.3, and we're going to kind of do a quick overview of all of the exam 4 materials, chapters 10 and 11. And we're going to start in our reviewing chapters, probably just chapters 1 and 2, maybe 3 is as far as we're going to get today. There's one thing I want to tell you guys about during the break, or at the end of the break. Today you have due Connect Math 11.2 and also Lab 10. You can turn in late for full credit today. Sunday, you got Connect Math 11.3 due. That's your last homework due. Your final is next Thursday. There's going to be a review session on Tuesday. We do not have class on Tuesday. We'll have a review session here, 5:30 to 7 or 7 to 8:30. And then also the final is going to be grouped by exam. So in other words, all of the exam 1 material will be kind of in the beginning, but within that exam it's going to be mixed up. Like, you know, the material in there. And then exam 2 material, and then exam 3 material, and then exam 4 material. Though I think there's like maybe one problem that has to move a page because of spacing requirements. And then the other exam will go exam 4 material, exam 3 material, exam 2 material, exam 1 material. Make sense? Mm-hmm. Okay. Question.
Timing of final, was that Thursday, 5:15 you previously agreed?
Yes, Thursday at 5:15. If you come at 5:15, then I can give you like that 10 minutes of bonus time at the end. All right, so we start at 5:15. Then instead of having an hour and 50 minutes, you can have that hour and 50 minutes plus a 10-minute bonus. So 5:15 on, sorry, so really this is really 5:15, final is 5:15 next Thursday. Everybody good with that part? Mm-hmm. Because the schedule says 5:30. If you come at 5:15, you can get a little bit extra time. All right. Here's the final study guide, the things that you should be studying from each of the study guides individually. All of the study guides are available on Canvas under exam study guides, as well as their solutions. Those are the problems you want from each of those. Oh, is that right?
No.
That's not right. Shoot, that's totally not right.
What's not right?
That study guide. Is that one right? This is the right one. So yes, here it is. I'm so sorry. So use this one, not the last one. Also, you are allowed to have 1 page, both sides, 8.5 by 11, 1 page, both sides, of handwritten notes by you.
Good stuff.
Yeah, you can use, if you have those little half sheets, you can use the 3 previous ones, just like Jeff has there. You can use the 3 previous ones, and then you can add a 4th one if you like, or you can just do it just like that. Good? Okay. You also want to, let's see, what other things that I was supposed to mention? Right. You're also going to want to bring your 3 tables, right? Your T table, your chi-square table, and your T table, and your yellow sheet. PPMC table, sorry. Your PPMC table, and you're going to also want to bring your yellow sheet. You guys, can you not talk today? Your yellow sheet. Good. And then also don't forget to bring your binder. So if you want your 2 points extra credit. These are my office hours next week. The ones in blue are study sessions. So if you want to talk to me about like what I'm going to do next semester because I may not pass, whatever, then don't come during those times. You want the black times. That's when I can meet with you and talk to you individually. Good? All right. All right, let's jump in on a quick review of chapters 10 and 11. Here's the first one. Dana, go ahead and read.
10.1 correlation coefficient. Little p or
Rho
or r.
Uh-huh.
All right. The range of the correlation coefficient from -1 to +1.
Right? -1 is the smallest it can be. +1 is the greatest it can be. This is a perfect line. This is a perfect line. And it kind of makes it, so +1 will be a perfect line. All the points line up and exactly on a line. This would be the same thing, only with a negative slope. Here in the middle, it's like the dots are just random scattered. So it's almost like a circle, right? They're all sort of randomly, like a great big fog of dots. So this means no line, no linear relationship, no correlation. If you reject H naught, this is H naught. If you reject H naught, then you'd say there is a correlation, there is a line. Good so far? Okay. This is our correlation coefficient, how to compute it that one time. Then you can just use stat test, Lin-Regge t-test, where you put your x's into list 1 and your y's into list 2. Round to 3 decimal places. So Lin-Regge t-test will give you your A and your B. For your regression line, it'll give you your R, and it'll give you your p-value. It'll give you a whole bunch of stuff. Hypothesis testing. Again, the key thing is H naught says that there is no correlation, not a line, not a line. If we reject H naught, then it is a line. And that would be this guy here, H1. Significant correlation. Good? So again, remember, H naught is always the nose. No line. No correlation. Here's our regression line. Again, you use your TI calculator and Lin-Regge t-test to find A and B. This is the important part. Dana, read the parts, the last 2 sentences in red and blue for us.
For valid predictions, the value of the correlation coefficient must be significant.
So that means that if I'm going to use that line, my data has to be a line. Right? I have to have rejected H naught. If I reject H naught in my test, then yay, it's a line. I can use the line to predict. Keep going.
When R is not significantly different from 0, the best predictor of Y is the mean of the data values of Y.
Right? When my R is close to 0, when it's not a line, when I do not reject H naught, then you can't use that line. You've got to use the best predictor is Y value. If there's no correlation, then my best guess at somebody's test score is whatever the average of the class was. The mean of Y, the mean of the scores. Make sense? All right, because who thinks that shoe size is related to how well you did in the test? Not correlated, right? So someone with a size 12 shoe, what's my best guess for their test score? The average, the class average. Makes sense? The Y bar, the average of the means. Or the mean, sorry. So this is, if you reject H naught, then you use that. If you do not reject H naught, then you use Y equals Y bar and X equals X bar. Oh, sorry. To predict. Your best guess at X, your best predictor of X is X bar. Your best predictor of Y is Y bar. How do you get those? You have a list. If you have a list in your calculator, can you find the average of that list? Yeah. Yes. 1 bar stats, right? Or 2 bar stats if you know how to use that. Good? Okay. Here is chapter 11, 11.1. Goodness of fit. This is saying that what you observe matches what you expected to get. So this is about proportions. It's one variable and categories. Right, like flavors of soda, or what else do we do? Days of the week. And how many do you expect to have in each one, in each category? So here, it's a list of numbers in each category. How many people are in each category? And remember, our chi-squared is the sum of our O minus E squared divided by E. where our degrees of freedom is the number of categories minus 1. So this one here's an example we did last class, right? So we had shopping bags used, that's our variable. What were the possible categories for shopping bag? Reusable. What else, guys? Read it.
Plastic.
What's the last one?
Paper.
Paper. Good. And then we had things that we observed. We observed how many people? How many people did we observe? Well, it doesn't say. It says 28 for paper. It says plastic is 120, and then the rest of the 300. So 152 were reusable. Our expecteds we have to calculate. Remember, our observed are what we actually get from our sample. Our expecteds we calculate. We take the total and we multiply it by some fraction or some percent. So if they were equally preferred, then we would just divide by 3, right? Multiply it by a third. But since they're not equally preferred, it's 60% reusable. So we take 60%, 0.60, and multiply it by 300. Make sense? This one here would be, plastic is 32%, so 0.32 multiplied by 300. So that would be 180. Everybody on board? Good. And then don't forget, this is the one where I do make you put down that your chi-squared, I make you write them all out. 152 minus 180 squared divided by 180 plus 120 minus 96 squared divided by 96 plus, there's only 3 of them. It's not going to be long. All good? But you can use your calculator, right? List 1, list 2, and then list, should we write that out? No? Who wants me to write it out?
Yeah, let's write it out. Go ahead.
Okay. All right. So then you can use your observed go into list 1, your expecteds go into list 2, and your list 1 minus list 2 squared divided by your expecteds, your list 2's, goes into list 3. Then you're not done yet. Your chi-squared is equal to the sum of your x's for list 3. This is 11.1.
Then you do 1 bar stats minus L3, right?
Yeah. So this, to get that, how do you get the sum of the x's? Good question. This you do 1 bar stat of list 3 to get that sum of the x's. That's how you get it.
GOF test, right?
Or if you have a fancy calculator, you can do a GOF. You have a fancy calculator, you can do a GOF.
Wait, is this the same thing as matrix?
No, this is not the same thing as matrix.
we
You
did it
cannot use a matrix for this. You will be SOL if you use a matrix for this. You'll get garbage.
I think
Does everybody understand this? This is not the matrix. This is a list. Do not use the matrix on this.
that's why
Everybody understand that?
Whatever.
Yes or no?
Yes.
Who understands that?
No matrix.
Okay.
No,
These are lists.
List.
Right? This is
This
a
one might
list.
not be wrong though.
You have 2 lists. You have your observed list and you have your expected list.
I think that's 10.
Everybody look up here real quick.
Something.
Eyes up here for a minute. You have your observed list and you have your expected list. Those are 2 lists. Does everyone see that? So we'll talk about 11.2 now. Here,
We're talking about
these are when we talk about contingency tables. Test of independence or homogeneity. So here, actually I'll do this second. Here, this is a contingency table. This is a matrix. Guys, this is my observed. This is a matrix. This whole thing is my observed. Yeah.
How do I know which one matrix?
Look at the data. Does this say observed? And does this say expected? No, these are categories.
So it has to stay observed.
Yeah, this would be observed. If this was observed and expected, then this would be a list.
But you don't normally give us the observed and expected though, right?
Well, I don't normally give you the expected. Yeah, you usually have to calculate the expected.
It's usually not a table when you do it. expected.
Yeah, sometimes it's not a table. Or if it is a table, this would be blank.
Right.
Does that also make sense? All right, so if I give you the data, this would be, yeah, it's the other way.
Yeah.
So this is categories here and categories there. Everybody on board with that?
So that's how we know it should be a matrix.
Yeah. One is categories here and categories there. But you gotta pay attention, because if we called this observed and expected and we gave you both, then don't automatically assume that it's just because there's stuff there. Gotta pay attention and see that, oh, those are categories.
Okay.
The other thing about this one is the H naught has 4 possible things it could be. They're all no's though. No relationship, no difference, no preference. No relationship means independent. Because either you're independent or you're dependent. Either variables are independent or the variables are dependent. Do you guys follow what I'm saying? If they're independent, that means that they're not related. Right? Everyone understand what I'm saying? In other words, if I flip a coin and I roll a dice, are those two things related to each other? No. They're independent of each other. They're independent. So, independent is the same thing as no relationship. Right? Remember we talked about me and my life? Right? I'm very independent. I do not have relationships. Okay.
Amen.
So, I have friends, right? But friends don't trap you into a relationship where you can't escape and you're... I have issues. So this is how, again, same chi-squared, right? The only difference is that you don't actually have to physically calculate these. Because the calculator will do it for you. You input the matrix, and it will calculate your chi-squared for you. But I do make you compute the expecteds. I don't make you compute all the expecteds. With the list one, you have to compute all of the expecteds. Right? You guys remember that? Like 60% of 300, 28% of 300. This one, you only have to compute the first one and the last one. Good? Of the matrix? The first one and the last one. So, for example, with the puppies, the first one and the last one would be... Erica, you're totally going to be on the camera. You realize that, right? The first one and the last one. Right, so you'd have to figure out what the total is here, figure out what the total is there, and it's the row total times the column total divided by the grand total. So the first one and the last one of the matrix. Good?
But you're not going to throw us off by using puppies in the test, right?
No, there won't be puppies.
Okay.
There could be puppies, but they won't be puppies. Yeah.
I feel like puppies didn't show up until now again. They were there in the beginning.
They were there in the beginning. I just bring the puppies in so you guys have a relative frame of reference.
Okay.
So you can see how that relates to chapter 4.
Yeah, I just don't want to accidentally do a chapter 4 on chapter 11.
Oh yeah, no. And then the other thing that's different is the degrees of freedom. It's row minus 1 multiplied by column minus 1. The number of rows you have minus 1 multiplied by the number of columns you have minus 1. Now the nice thing too is when you do this chi-squared test on your calculator, it will give you the degrees of freedom, so you can double check and make sure you did that right. Should I walk you through? You know what? I'll show you guys really briefly, really quickly, again, how to get to the matrix. So to get to the matrix, you do second, and then below that is matrix right down here. Some of you might have an old calculator, and on the old calculators, the 83s, somewhere right around here is a button that literally just says matrix on it. So, and that's easy. Then you hit that button, and you get here. And then you go over to edit, and the very first one's A, and enter it, and you change that to whatever you want. So if I want the puppies, we had 2 rows, male, female, so I do 2 by 3, and it makes it into 2 by 3. Remember, it's RC cola, row then column. So row, 2 rows, male, female, 3 columns, black lab, chocolate lab, yellow lab. And then you just put the numbers in there, and then it'll calculate it for you. So you just hit enter, and it just kind of runs you through all of these numbers. You just type them all in there, and hit enter, and it just moves around. Then you go to stat, test, chi-square test, and you want to put your observed, you put your observers into matrix A, it will calculate your expecteds and put them into matrix B. It'll overwrite whatever is in matrix B and put your stuff in, your expecteds into that. So you have to do anything with matrix B, it will take care of that for you. You just have to put your stuff in matrix A and tell it that your observers are in matrix A and it'll do the rest for you. It'll store stuff in matrix B, to calculate, and it will give you your chi-squared, your p-value. Is my p-value 3.67?
No.
No, it can't be more than 100%. Your probability can't be more than 100%. So if you have a number larger than 1, you better be looking for what? E negative something at the end. This is E negative 5, which means you add 5 zeros to the beginning, put the decimal place after the first 0. Okay? And then my degrees of freedom is 2, so you go always double check and make sure you got that right when you figure out your critical value. Alright, so why don't you guys take a minute if you need it, 2 more minutes, and work on quiz problem 1.
Right.
2 minutes, 1 minute?
How do you
2
rank them
minutes.
with 5? There's not
2
enough
minutes.
evidence to reject. Or there is enough evidence to reject
There
the claim.
is enough evidence to reject the claim that being the victim of a crime